Okay, so this lesson we're going to look at the second half of section 8.4, and so we're still talking about fitting normal distributions to data and comparing to evaluate data values using z-scores. We're going to go a little deeper into z-scores and talk about how those can find us exact percentages compared to the percentages that we have in the empirical rule, where it has to be perfect standard deviations away. So we're going to look at today something called the standard normal distribution. This allows you to compare values of different population distributions. In a standard normal distribution, if I'm looking at the table, remember that the center value is the mean, and so the mean of this data set then in a standard normal distribution is 0. And then what value am I adding or subtracting each time to get the next values? That's the standard deviation. So since these are all single unit increases and decreases, that means that the standard deviation of the standard normal curve is 1. The total area under the curve of the standard normal distribution is equal to 1, and so that represents 100% of the data values. So if I'm going past those 3 standard deviations, that contains 100% of the data, versus, remember, we know that if we stop at 3 standard deviations, that only represents 99.7% of the data. So the percentile of the data value is the percentage of values that are less than or equal to a particular data value. So what that means is that we're looking at the area of the curve to the left of that data value. So if I think about it as a standard normal curve, and I have a data value, I'm finding the percentage of values to the left of that. Okay, so using something, using the z-score and the z-table, we can find these percentages precisely. So if we were in class, you would get a paper that has this on both sides. So these are standard normal probabilities depending on the z-score. And so notice that the ones here, if I think about the mean is in the middle, here, these are ones to the left of the mean, and then that value, so notice the z-scores here are negative, the ones to the right of the mean, the z-score values are positive. So we're going to use these tables to find percentage values. If we were taking a test, you would get this for the test. We've placed them in the notes though, so you can kind of write on it and see where numbers are coming from instead of just having the table and forgetting how you used it. So we're building on from what we did in the last lesson. So the weight of a captive adult female lowland gorilla is normally distributed with a mean of 82.3 kilograms and a standard deviation of 15.33 kilograms. So if Sasha weighs 61.8 kilograms, they want us to calculate the z-score for Sasha and use this to find the percentage of captive adult female lowland gorillas whose weights are less than or equal to Sasha's. So in order to do this, we want to start by finding the z-score. So we're looking at what they give us. So within this data, they're giving us Sasha's weight. Remember, that's our data value, that's X. So X is 61.8 kilograms. They told us that the mean of the data set, or of the weights of these gorillas, is 82.3, and that the standard deviation, or sigma, for these weights is 15.33. So that means that if we want to calculate Sasha's z-score, we're going to take her weight, 61.8, and subtract the average weight, 82.3, and divide that by the standard deviation of their weights, which is 15.33. Okay, so if I do 61.8 minus 82.3 and divide that by 52.33, that gives us a z-score for Sasha of negative 1.34. Oops, I didn't write the negative. Of negative 1.34. So what we're going to do from here is now use the z-table to identify the percentage of females whose weights are less than or equal to Sasha's. So this means that I'm straight up just reading the table, looking at the z-score. So her z-score is 1.34. So the negative 1.3 is coming from this value on the z-score table. So because it's negative, I'm looking at the negative side. So I'm finding negative 1.34 using this. We just clipped this to be in the notes so that you could write on it. And then negative 1.34 is the next value. And so that's coming from here. So what that means is that this decimal represents the answer. So looking at the table, that gives us 0.0901. So remember that to write something as a percentage, we're going to take that decimal and move it 2 values to the right. So that means that it's 9.01%. Have a weight that is less than or equal to Sasha's weight. Okay, so again, this is only because it was less than or equal to, so that is the shading to the left. So they're saying that if I have this value here, that this is 0, this is -1, this is -2, that Sasha falls somewhere in here, and we're finding this percentage. For this second question for part B, they want us to find the percentage of captive adult female lowland gorillas whose weights are greater than or equal to 118.1 kilograms. And so they're giving us a new value for X. So this time X is 118.1 kilograms. The mean and standard deviation are the same. We're still talking about these female lowland gorillas. So our mean was 82.3. And the standard deviation was 15.33. So if I'm calculating the z-score, I'm taking 118.1, subtracting 82.3, and dividing by 15.33. And so that's going to give me a z-score of about 2.34. So remember that if this is asking me for whose weights are greater than or equal to, I'm thinking about this as here is 3 standard deviations. So if I want 2.34, I want to find this percentage. The problem with the z-table, though, is that the z-table tells me the rest of it. So this percentage, oops, I didn't change the colors. So the percentage of the rest of the graph, so all of this is what the table will tell me. Okay, so when I look up 2.34 on the z-score table, so I'm looking at positive 2.3 on the left side, and then 0.04 across the top, that's going to give me the decimal value of 0.9904. So that means that 99.04% of the data is here. So what I think about here is if I'm asking for something that's the opposite of what the table does, I'm just finding the rest, right? So that means that in order to find the rest, I'm going to do 100% minus 99.04%. And so that's going to give me a value of 0.96%. We could also just say that that is about 1% of the data. So if it's asking me for the weights greater than or the values greater than the z-score, I have to subtract the percentage from 100. There's another trick that you can do for this. And what I can do instead is I can look at, so this is when this is telling me it wants the value that z is greater than or equal to 2.34 versus this one was giving us, it wanted the value z is less than or equal to negative 1.34. So when it's less than, I'm just looking at the table. When it's greater than, I have to find the less than and subtract it from 100. An alternative to that, I could look at negative 2.34. So if I look at the z-score table for the negatives, negative 2.34, notice gives me 0.96%. So that value plus the one for positive 2.34, those two numbers should always add to 100. Okay, so if I'm finding the area above a number, the alternative is instead of having to subtract from 100, I could just look up the opposite z-score. So if my z-score is negative, I would look at the positive side. If my z-score is positive, I would look at the negative side. Again, that's only because I'm looking at a z-score of greater than those values. Okay, so in the next example, the last example, we're gonna look through and review some stuff that we haven't done for a little while, which is calculating standard deviation. So we're using standard deviation the last couple of days, finding z-scores and looking at empirical rule. And so now we're going to calculate the standard deviation in order to find some z-scores and answer some questions. So a random sample of the number of goals scored in a hockey game is represented by the dot plot. So the dot plot tells us how many goals are scored in each game, and they're giving us values using that. First thing they want us to do is find the mean and standard deviation of the number of goals to the nearest tenth, so 1 decimal place. So what we want to do then is put the data set in order, which it already is because it's in a dot plot. So remember that each dot represents a number. So since this is labeled as 2, that means we have a 1. So 1 game that scored 1 goal, and then 2 games that scored 5. So 1, 5, 5. 3 that scored 6. 2 that scored 7, 1, 8, and 1 game with 11 goals. Okay, so we're just translating the dot plot into a data set. So we want to find the mean first. The mean is the sum of all the data divided by the number of data values. And so if we look at this, we have a value for n of 10 because we have 10 different numbers here. So when I divide to find the mean, I'm going to divide by 10. If I add everything together to find the sum of my data, that's going to give us a sum of 62. So the sum of all x values is 62. And if I divide that by 10, that gives me that the value for the mean is 6.2. So to find the standard deviation, I now need to take that mean of 6.2. I'm just going to draw a line so I know that that's the number for the whole data set. So remember, I'm going to do that number, x minus the mean, and then I'm going to take that each of those numbers and square them. So if I do 1 minus 6.2, that's going to give me negative 5.2. 5 minus 6.2 is negative 1.2. One of the benefits to putting the stuff in order is that once I do it once, I can just draw that same number until I get to the last value. So 6 minus 6.2 is negative 0.2, and I have 3 of those. 7 minus 6.2 is 0.8. I have 2 of those. 8 minus 6.2 is 1.8. And then 11 minus 6.2 is 4.8. So remember that I'm not doing anything with these numbers together, but I am squaring each of them. So remember that when I square a negative, it's becoming positive. So if you're using your calculator, you put parentheses around it. Always just remember that these numbers, because they're squares, they're always positive. So if I square negative 5.2, I get 27.04. If I square negative 1.2, I get 1.44. The square of negative 0.2 is 0.04. The square of 0.8 is 0.64. Square of 1.8 is 3.24. The square of 4.8 is 23.04. So these numbers are the ones that I'm summing. So the sum of all of these values, if I add all this up, I'm going to get 57.6. So the sum of all values is 57.6. I have to take the square root of that divided by the number of values, which again was 10. So I'm essentially taking then the square root of 5.76, which is, so sigma is about 2.4. Okay, so my mean is 6.2. The standard deviation is 2.4 for this data set. Use the data given in the problem to find the percent of last year's games that had at least 7 goals. So that means that we want to find 7 or more is what at least 7 goals means. So that would be these values. So 7, 7, 8, and 11. So there was 4 out of 10 games where that occurred. So that means that I would do 4 over 10. So that would be 40%. Okay, so 40% of the games in this data set had at least 7 goals. Next, this is asking us to estimate the percent of games that will have at least 7 goals using the fact that this is normally distributed. So we're estimating the percent, not taking our data, we're looking at the estimate of the percent. So what they're telling us is that we want to find z greater than or equal to some number for this. So the value that they're looking for is 7. So we're finding the z-score when x is 7. We calculated that the mean of the data is 6.2 and that the standard deviation of the data is 2.4. Okay, so the z-score for this then is 7 minus 6.2 divided by 2.4. So that, if we calculate, is going to give us a z-score of 0.33. So we're looking for when the z-score is greater than or equal to 0.33. So remember that this represents, if I were to have a standard normal curve, it wants to find this percentage. So if I look up 0.33 on my Z table, that's going to give me the percent of the value that's not shaded. So if I look on the positive Z table for 0.33, that gives me 62.93%. Okay, so that gives me 62.93, but remember that that represents this one. So I'm either going to do 100% minus that 62.93%, or remember the alternative is I'm going to look up negative 0.33. If I look at negative 0.33, so 0.3, so 0, 1, 2, 3, that gives me 0.3707. I just want to make sure I'm in the right column. So negative 3.3 gives me 37. .07%. Okay, so that would mean that this represents this value. Okay, and so notice that if I do subtract 100 minus 62.93, so that gives us about 37.07%. So if I think about my answers for B and C and compare them, so B was using the actual data 4 out of the 10 games. C was given knowing that it's a normal distribution. So if I were to play more games, it should fit the same curve, and so that would give me a better idea of how many games out of 20 I would have if I were to continue this data. So those 37 is a good estimate of 40, and so we can see how they are related there. So remember that the big idea here is knowing how to find a z-score and use that to identify the percentage of data either below that z-score or above using the standard normal probabilities table. So calculating the z-score and then looking it up. If I'm looking for the shaded region to the right, then I either look up the opposite z-score value. So if it's positive, I look up the negative. If it's negative, I look up the positive, or I subtract that percentage from 100.